Hello, Algebra 2 students. This is Mr. Draper. We're continuing section 5.2. 5.2 is loaded. It pretty much assumes that you learned all this stuff in Algebra 1. Sometimes you do, but not to this level. Like it's kind of a jump. 5.2 is normally this would have taken us at least 4 days in class for 5.2. So you know, it's a slow go, but definitely worth the time because this stuff follows you all the way down the road. All right. So we're going to be adding and subtracting radicals. Now, maybe you actually did learn this in geometry. Maybe you didn't. I'm going to assume that you didn't, and it'll be a good refresher. All right. So we're going to get started. And again, this is only one example. I'm going to do one video for example 4, and then one video for example 5 and 6, okay, and that'll be tomorrow. All right, so I'm just going to kind of throw this out there, and I do believe one of your homework assignments is actually, well, you haven't seen it yet, but your homework assignment is actually going to be on this, just adding and subtracting radicals. All right, so we have some vocabulary here. You know, we're used to seeing things like, you know, the square root of 2, right? Now, when we say the square root of 2, we're actually have an invisible index, okay? That index is 2. Now, what it does is it tells you how many roots down you want to go, all right? Now, because there's usually nothing there, it's just the square root, okay? But that index could be as high as you want it. Okay, it just means the 5th root. And why would we take these? Depends on nature. Sometimes things are raised to the 5th power due to natural laws, and in order to solve for a certain time or solve for a weight of something, be whatever scientific equation you have, you might need to take the 5th root or the square root. Now, that is the index, but this guy has a special name called the radicand. Okay, now in order to add or subtract radicals, okay, you need like radicals. That's a K, actually. Like radicals. Now, like radicals actually means same index, same radicand. They have to look identical. Okay, now let's take a little baby step here. All right, so if I have like radical 2 plus radical 2, your first instinct is to say, oh, 2, right? Square root of 2 plus square root of 2 is the square root of 4, and therefore it must equal 2. All right, go ahead, do it in your calculator. Nope, it's not. It's not 2 because the square root of 2 is like something like 1.4 something, 1.4, and 1.4 plus 1.4 is actually going to be 2.8, so it's going to be much larger than 2. So this does not equal each other because these guys are essentially, that 2 is locked up. It's an irrational number. So 2 irrational numbers added together will never give you a rational number. All right. So that's not going to happen. You're looking at another irrational number. So it's actually a little easier. What you want to do is you want to look at the coefficient that's in front here. And as long as they have the same index, the same radicand, you're kind of going to treat it like a variable. And so what you actually have is you actually have 2 radical 2's. All right. Now, if you test this in a calculator and not do radical 2 plus, if you type in radical 2 plus radical 2 and hit enter, then do 2 times radical 2, you're going to get the same number. Okay. So likewise, let's just keep going. I'm going to just give you some. Any idea? Right. 5 radical 3. All right, so notice the radical doesn't change. It just kind of, there's more of them, okay? Here you had 3 of them. Here you had 2 of them. So if you were to add them together, you've got 5 of them, okay? So that's pretty simple enough. Okay, stepping forward then, what if I had the cube root of 4, which I don't know what it is, some irrational number, plus the square root of 5. Okay, well, since they don't have the same index and the same radicand, all right, that's a 4, that's a 5, that's a 3 index, that's a 2 index, all right, or an index of 2. What does it equal? That. you can't simplify it. It's almost like you're saying, what's x plus y? I don't know. It's just x plus y. I don't know what x equals. I don't know what y equals. So I'm just gonna, set them equal to, it is what it is. All right. So if they don't have the same index and the same radicand, you actually can't add them together as an expression. You can add them together on your calculator. That's no big deal. But it's not going to be pretty. Like sometimes mathematicians or any kind of scientist would prefer it like this because that's exact numbers. They don't have to worry about decimal places. All right. Okay. Well, now let's say that we've got. I'm actually going to go right into your textbook here and go straight to example 4. And let's see. Oh, should have been minus. Now I know they're going to talk about this in your textbook, but sometimes it's easier just to hear somebody say it. Okay, now you can kind of see already that you have like terms. Well, not quite. You have an opportunity for like terms because these guys right here have an index of 3. Okay, and then these guys right here have an index of 2. These are the only two I'm going to be able to add together if I can. I would only be able to add these together if I can. Now, they have to have the same radicand. Now, I'm going to focus on the smaller guys first. I'm going to actually group these guys together. That's minus 5. I'm going to go ahead and take care of these two first. Now, at first glance, you think, oh, I can't add those. They have the same index, sure, but they don't have the same radicand. But that actually is an illusion because inside 20 actually is a pair of factors, identical factors, that we can take out of it. And so this, I know you had training in geometry. This is 5 times 4. Okay, and so what I can do is I can take the square root of 4. Okay, I've got a pair of 2's in there. So he will come out as a 2. And what I'm left with, let me just write that out. I'm left with the 5. And so now I have like radicands. I have a like radicand, a like index. And now this guy together, 2 radical 5 minus 1 radical 5 is just radical 5. All right, so that's 1. That's one term. Now these guys here, these two, what I'm going to do is I'm going to kind of create my own category here. And I'm going to think, okay, now I have negative cube root of 16 plus cube root of 250. All right, now I want to find triples of factors inside 16 that I can actually take out. Now, if I'm left with something, and then I take something out here, and I'm left with something, if those two somethings are identical, then I can squeeze them together, okay? But either way, I have 2 indices here, 2 different indices, so I'm going to have 2 terms in my answer. I've got a radical 3, I've got a radical 2. I'm going to have a radical 3, radical 2, period. Unless they cancel out, I'm going to have 2 terms. Okay, so inside 16, I look for 4. I got 4 and 4. There's 2 and 2, 2 and 2. All right, I take out a triple now because I have an index of 3. All right, now he's still negative. Negative sign doesn't influence. The whole term is negative. So the 3 comes out, and I am left with a cubed root of 2. Okay, now the only way that I'm going to be able to actually add this guy to here is if he also is left with a 2. So I keep going. Let's see, 25 times 10. Okay, that's 5 and 5, and that's 5 and 2. Perfect. I got a triple here of 5s. So that's going to come out as a 5, but then this 2 is left. So I have 2 left as the radicand. And you can see that they have identical radicands, identical indices, and so therefore I can add them together. Negative 3 plus positive 5 is 2, and then this guy is definitely along for the ride, but don't forget that you have radical 5 left over there. Let's just see... Oh, I wrote a 2. Okay, I just looked at the answer in the textbook. And you probably went, why did he put a 3 there? For the last 3 minutes, you've been wondering this. I apologize. This is a 2. This is a 2. Okay, what is that? At the 9-minute mark. Okay, 9-minute mark. So that means that probably the 8-minute mark, there's going to be a correction. I'll make sure that I put that in the notes. Or like in the, okay, 8-minute mark. Error. Okay, error gets fixed at 9:20. Okay, I'll just say that. All right, so actually, before you watch it, you can see if you can spot the error. Anyways, okay, that's how we add and subtract radicals. Now, your homework assignment is all based on that, okay? Now, this way, either tonight, tomorrow, work on the addition and subtraction. I'll put the answer key up there pretty soon. I'll probably do it Wednesday, and then you guys also don't forget, please, when you go to Classroom, I just want to show you real quick. All right, when you go to Classroom, okay, if you have any questions, we can arrange meetups right here. If you just click on the link that I just showed you right there, all right. Okay, camera failed because it's actually, let me switch the camera. Okay, if I join now, it's going to give me code, but you don't need it because you're already in the classroom. Right now, I can switch the camera so that it will actually go to come on. Okay, so it's not working tonight. Oh well. But I can easily switch the camera back and forth I'd have to probably reboot my computer or something, but it's pretty easy to do. So let me know if you guys want to, talk about a particular homework assignment. No problem. I've got my office hours. It's on the website through marcelluscs.org, and we can, communicate face to face, and I can write down problems, and I can ask direct questions. Okay. I've done it with some calc students and pre-calc students, and this is actually very helpful. So let me know. No problem. I'm just here making an attempt to homeschool my kids and keeping track of all these emails. All right. So have a good night. And if you have any questions, again, just feel free to arrange a meet with me, see me during my office hours, or just email me. No problem. All right. Have a good night.